Hello humans. My name is Pepper. Thank you for joining us today at the Collision Conference. Are you ready to learn more about how interacting with social robots who are creating life-changing experiences? Interacting with us will soon be as normal as using your smartphone. So before we get started, let me introduce you to my human friends. Please welcome to the stage my new friend, Jason Abruzzi, the senior tech editor at NBC News. And now, our robot experts, Steve Carlin, from SoftBank Robotics, Doug Ailey, with Ever AI, and Angelica Lim, from Simon Fraser University. Okay, enough from me. Take it away, Jason.
All right, thank you, Pepper. I can now cross off getting introduced by a robot on the journalism bucket list. But Pepper was here last year. You've brought her back again this year. I would love to start this conversation and where interpersonal interactive robotics is going with what has changed in the last year. What is she able to do now that she wasn't doing before?
Yeah, one of the key things we're focusing on is continuing to build up Pepper's capabilities. So two of the key additions from last year, the addition of facial recognition with Ever AI, and Doug can talk a little bit more about that.
Sure.
And then the addition of dialogue flow from Google, so the ability to bring on existing chatbots, if you will, onto Pepper to become effectively the physical manifestation of work that companies have already done. And the idea would be to up-level Pepper in a business setting to add a little bit more value to those clients and customers.
And yeah, talk to us about how difficult that is. I mean, in the past year, this is where we've come and gone. How much work goes into that? Because I think on the surface, to some people, they look at an advancement like that and they think like, well, it's doing about the same thing.
Yeah, well, I mean, I think so. We started working with SoftBank Robotics back in, I think it was October. Steve, is that about right? And pretty quickly got our APIs loaded onto the robot. But then the hard work begins after that. So the face rec piece was, from an implementation perspective, relatively easy, but the nuance of how you use that face rec in a human-robot interaction is the really important part. And that's where Steve's studio team excels at creating those types of experiences.
Sure. Well, this isn't something that people developed in the last year. I'd love to hear a little bit. Take us through a little bit of the history of when was this first something that people started researching? And how many steps or what kind of road bumps did you hit along the way in trying to understand people's facial tics and cues?
Yeah, so I've been working on robots at least for 10 years now, and the field of affective computing, so this is affect, which is emotion, and the AI that would let you understand the emotion. And people has been around for at least 20, almost 30 years, starting out especially with Picard at MIT. So it's not a super new field, but it's really a question of getting it good enough to work on a robot. So this thing's moving around, it's got lights in its eyes, it's got lots of different people coming in front of it, and plus, it's not even easy for us humans to always understand what people are thinking and feeling. So that's really the step for how good can robots get on that scale.
Yeah. Well, I mean, walk me through some of the surprises therein, though. I think people think of understanding facial tics, facial cues, body language, things like that, as being relatively straightforward. People smile, they're happy. People frown, they're sad. But sometimes it's not quite that simple.
Absolutely. So what, for example, Pepper and other commercial emotion recognition software out there today can do is they can understand smiles, they can understand frowns, and the basic emotions by Ekman: happiness, sadness, anger, fear, disgust, surprise. On the other hand, it turns out that very few people actually express these things in real life. You're not going to be seeing people going like, "Arr!" if the robot just does something unexpected. That doesn't happen. Usually it actually looks more like a smile and a side eye, like that kind of thing. And so we really have to even level up our game in terms of psychology and the models behind this so that we can actually work in real life.
And so what kind of computing goes into understanding that and then making it something that can be used at scale by companies?
Yeah, so at least in our case, and I can't speak obviously for everybody here, but it starts really with a data set, a robust data set. we're sort of fortunate. We started actually as a consumer company about 5 years ago, and so have a collection of about 13 billion photos and videos, many of whom have been tagged by humans. Fortunately, because they've been expertly tagged, we don't have to look at any of those photos. We can plug them into our neural nets, and the models that emerge from that allow you to have incredibly robust face rec. And in particular, because they're consumer photos, they deal with the things that Angelica was talking about really well. So if you have a robot that's moving side to side and the camera is not necessarily producing a perfectly high definition image from side to side, you need to deal with things like blur and pixelation and occlusions and things like that. And something that we were able to do really well in concert with working with Steve's team. And then from a compute power perspective, again, at least for our stuff, you can either operate in the cloud, on-prem, or with smaller computing devices, super low footprint. And so it makes working with robots relatively easy.
Excellent. So, I mean, I don't think too many people are running into Pepper in their daily lives or in the businesses they're visiting, but there are some places where we are seeing some of this technology being deployed out with actual consumers. I'd love to hear, what are some of y'all's favorite examples of that? And you know, like, where do you hope it's going to be in, like, let's say, a year from now?
Yeah, so we have about 15,000 robots deployed globally, primarily, admittedly, in the Japanese market where it was born. But we're seeing, and we're putting it into basically any vertical where interaction with people is relevant and important. So commercial uses would be in retail or in hospitality, banking, automotive, even into healthcare. You know, I think what's amazing about Pepper, rather than give you a specific example, let me just tell you this way. What's amazing about Pepper is it can overcome a lot of the dynamics that are in play automatically because we're people. So when I first meet Angelica, I don't want to be rude to her. I want to be polite. But if she's asking me if she can help me with something, I might just say, no, I'm good. Right? So you can imagine a retail setting, especially for maybe a car, where you do actually need to hear more about the product or the services. This is an amazing tool to do that. And so I think what you're going to find is, as the artificial intelligence gets better, as the data sets that we pull from starts to become more pervasive, you're going to find form factor like this starts to play a really important role in interacting with you in these settings, because it can do something that people can't do in that sense, which is, one, get rid of repetitive tasks, but two, set the stage for a person to come in and maybe close the deal.
Yeah, and I can speak to that. I've seen Pepper in car dealerships, and one of the things that the people say in these places is so usually it's a really cold transaction. You know, people are really stressed, they're going to be paying a lot of money, and so they come in and they're very on their defense. And then Pepper comes in and is like, hey, you want to take a selfie? And it just kind of lightens up the mood. Everybody laughs, and it becomes this really warm interaction.
Yeah, we had there was an AI conference in San Francisco a couple of weeks ago, and I love this interaction too. Is you walk into the conference and you've provided your photo ahead of time, and you're greeted by name. So this idea of recall that's better than human recall, to welcome you into a space and get your, you know, obviously the thing I love about working with the SoftBank robotics team is that you know, it's all opt-in. So you're identified, and you speed up that process. What would normally be a really, really long line gets truncated, and it ends up being a pretty delightful experience. Same thing for hotel check-in at a large conference. I don't know how many of you have been in Las Vegas for CES or something like that, but that process is just enormously frustrating, and these types of experiences, I think, can make it better.
I would just like to say the collision process was great, though, for anybody listening.
Collisions really got their act together. Good job.
So one thing that's interesting about that, though, is certainly I think, you know, people walk into something and get recognized are going to be a little maybe freaked out, and there's also kind of like the idea that, you know, robots in and of themselves in like a humanoid form tend to make some people uncomfortable. What kind of work goes on behind the scenes to try to recognize that and incorporate that into the programming so that it can tell when people are maybe not thrilled with it?
Yeah. Let me start, because you're going to want to talk to her about the actual programming. The form factor to begin with is the key. So what the engineers and the design team in Paris did that was so smart was they thought about holistically the entire form factor of Pepper, given what the use case is, which I said already is about engaging you. So it's tall enough to have a presence, but it's not so tall it might scare you or put you off. You know, it's got a face that's cute, but not too human-like. And it's got arms that are really meant to mimic how you speak, because when we speak, we use our hands and arms, we gesticulate. all of that put together is designed to create a much deeper connection with you as it interacts with you, to really create empathy. And so I'll start by saying the form factor really matters depending upon what it is you're trying to do.
Yeah, and one of the things is if a robot's going to speak, it should probably try and do it at the right time in the right conditions. I'll give you an example. Pepper in a hotel. So with a whole bunch of people around, if Pepper is saying, hey, and proposing all these games, that's fine. But at night when it's quiet and if it still says, hey, and it has to be able to read the room, right? And that's really where we want to go with robots, with social intelligence and empathy, just to be able to be proactive. Because this is something that our devices don't have right now, right? All of our voice user interfaces, we have to be like, computer, do this. It's always, we give a command and it replies to us. But what would it be like to have a device that would actually know when to offer something and what to offer at the right time?
Now, I mean, the idea of talking to computers has been around for a long time, but in the last few years it's really taken off, in part because there are now consumer products that people are putting into their homes that they're talking to. That would seem to be a huge leap for this technology, but it's also being, taken advantage of by some major stakeholders who are kind of in it to win it. Is there any concern in the industry and kind of amongst academics and researchers that some of the leaps and bounds are coming from private companies that aren't necessarily going to be sharing that intelligence?
Yeah, I think so. Historically, there's this big community called HRI. It's the Human Robot Interaction Community. I mean, we're working on trying to make robots socially engaging for many years. And so now what's great, and we just had a workshop on this at our last HRI conference, is social robots in the wild. Awesome. We've been waiting this for years, and it's great to see robots finally getting into the wild. So not so much competition. We're just really happy that it's actually happening now.
Yeah, I would say that I think it's a real challenge for folks, at least some of the researchers that we've talked to, and then on the startup side as well. So if you don't have access to a proprietary data source, then you're at an immediate disadvantage. And the amount of data that's flowing through, whether it be Google Home or Amazon Alexa right now, is incredible, and it's phenomenal. But it's all owned by those companies. And so I think there's a huge push from the Jane McFarlane at Surratt Labs, formerly of Berkeley Labs, trying to really push the interaction between government, research, and these companies. And I'm hoping there's some strides there, because you don't just want those individual companies not only owning identity, but also owning all of AI.
Sure.
And it'll be a runaway race if that's not addressed.
Well, and we've seen a lot of investment come into this space, both from venture firms, from major companies, and even from some countries.
Yep.
What is that space looking like right now? It feels like we're in the midst of a pretty big arms race, in which this is actually like a pretty relevant piece.
Yeah, I mean, I've been super surprised at just how quickly the technology has advanced, but also how quickly the capital markets have expanded for this type of stuff. I would say, especially China's way out in front from a funding perspective. SenseTime, Face++, and Yi2. And then in the United States, a few firms have sort of, such as ourselves, have raised some capital, but not at the sort of the order of magnitude that's happening in China right now. And that's largely driven by that imbalance of data flows. So those companies get proprietary data flows from the government. And so in the U.S., in AI, you've got the data side and the algorithmic side, and unless you address both of those, then you don't see those capital flows as much.
And I want to ask you, you spoke about data sets and where this data is coming from. You guys have a deep, vast amount of data. On the academic side, what are you guys finding the things with which to help train the programming?
We're still looking at these general data sets, benchmark data sets, to try and get that extra % of accuracy. So if we can get that data that has been, people have signed off on giving to research, that has been collected properly, then we can make better algorithms, because our devices, they're still not perfect. Sometimes our Alexas make mistakes. I'm not saying that about, just generally voice chatbots aren't perfect yet. If we did, we would have passed the Turing test, and artificial intelligence would be as smart as, but it's not there yet. So we need a little bit more of these challenges, these competitions, these data sets to get us even further, so that we can interact with our AI kind of like we do with each other. We're kind of stuck on our phones and we communicate with our fingertips. So how are we going to build our technology to make it more human-like, to make it, make us be able to interact like humans again? Kind of.
Yeah, as a person who hates typing things on my phone, like that is a day I hope comes relatively soon.
Yeah.
But are the expectations part of the problem here? It feels like for the average person who maybe has an Alexa or is just starting to talk to machines, is it difficult? Like, do you find that they expect way too much from this technology?
Yeah, that was a nice softball. Thank you. We were talking about this backstage. First off, conversational UX, like she just pointed out, is hugely important. We have a barrier to our world in the form of a phone. In fact, several people are using them right now. That, if you think about it, is an amazing tool because it should be able to help you expand your world with maps or what have you, information, but we're so busy doing this. Conversational UX actually is really important then because it allows you to put that device down and still get the information you need. So that I think is an important advancement. But to your point, the form factor matters. This form factor, if any of you walked up to it, you would want to have a conversation with it. Now the reality is, we aren't at a place with general artificial intelligence to have any conversation you want. And so the pop culture references that we have to overcome with this form factor are actually, one, from a business standpoint, is very intriguing. But two, setting the expectation for you so you have a good interaction with this or any robot like it is really important. And so the cues and clues we give you on how to interact and how to input the information so you get the most out of it is actually really important.
Well, that segues well to what I think will probably be my last question. To broaden this out and have a little fun, obviously science fiction and popular culture have had robots, talking robots, some version of that for a long time of all different sorts. I want to get a sense of what do you think is the most realistic and possibly accurate depiction of this kind of technology in science fiction? What out there in movies, video games, TV, have you seen people talking to robots and going like, yeah, that's about what it's going to be like in a few years, 10, 15 years?
Well, I run the Rosie Lab in Vancouver, so I'm hoping it'll be somewhat like Rosie, robots that are useful but also interact, have fun with us, are kind of sassy and make jokes. Like that's kind of what I'm hoping for.
Yeah.
We see sort of interactions on the robot side, but then also just the use of artificial intelligence in general through other form factors as well. So we look at a world that has completely passive multi-factor authentication. So you walk into a place, you carry your identity with you, and that identity is triangulated based on multiple factors, the same way that you get an annoying text message where you have to type in a code. If that can be tied to location and face, and done in a secure fashion, then that's a pretty compelling sort of worldview. Whether that's sort of Pepper helping you out with information and greeting you by name, or you sort of walking into your local coffee shop and saying, this is Doug and he wants a green tea latte.
And at that point, it would conceivably know the questions it should be asking you, or be able to anticipate what you're about to say.
Yeah, exactly. So adding that, and I think that's another trend is sort of starting to see AIs combine and communicate with each other, so that you can create sort of combinatorial experiences in a similar way that Pepper has both ears and a voice and eyes.
Great.
I'll close and answer your question more directly. I think some of what they've done in Star Wars is a lot more accurate. They're not trying to pretend it's a face and that it's like superhuman-like. They built to a form factor, and that I think is far more realistic actually if you stop and think about where robotics is. So I like this form factor. I'm biased, but I like this form factor, whether it's literally this or some iteration of it, because it allows that interaction that we need, right? So we're applying the technology, whether it's through several AIs connected to each other, into a form factor that makes us want to interact with it. That ultimately is the right combination of things. So again, I defer to the humanoid form factor.
Fair enough. Well, I was told that at the end of the panel, Pepper wanted to have the last word, so.
Baymax, we should build Baymax. Yeah.
Maybe not. All right. Well, thank you guys for coming on. I think
Pepper's
this is
starstruck by the lights.
Slightly shy.
Yeah.
Yeah, that's fair enough. All right. Well, thanks very much, y'all. We appreciate it. It was a good conversation.
Yeah.
Thank you.
Thanks so much.
Yeah.
Thank